This is going to be part one of the next section, and we're going to start getting into some more factoring, but this time we're going to be solving some more complicated things. So just be sure to get this information down, and it shouldn't be too complicated, but it's going to be brand new, so it's going to take you a second to kind of see the patterns and get used to everything. First of all, we should all be familiar with the GCF. We know that the greatest common factor is something we can take out. So, like look at number one. I'm just going to roll through some of these examples. So, number one, we've got 12a to the third plus 10a. We need a greatest factor between those two that they have in common. That's the greatest common factor. So first, let's look at 12 and 10. We could take out a 2 out of each of those, and that's the greatest thing we could take out. Then we can also take a look at our variables, a to the third and a to the second. A to the second tells us, first of all, since they're both a, you go to your least exponent, which is 2, so you can take out an a to the second out of these, and I can't write for whatever reason. Okay, there we go. So we've got 2a to the second we're taking out of both of those, which will leave us with 6a plus 5 in parentheses. So essentially all we did was take out the GCF of 2a squared. So I think we probably all should be good on GCF. Now, difference of squares, we did this a little bit. We're going to get into it a little bit more. So perfect squares are any number that can be that you can take the square root of it evenly. So numbers like 1, 4, 9, let's see, 16, 25, 36, 49, and so on. The rule for this, so the way that we rewrite this is if we can square a and we can square b, meaning that we can take the perfect square of those. If they're perfect squares, we rewrite this a minus b times a plus b, which we've done this before, so I think you should be pretty good with this, but I'll do an example anyway. So number 3, we've got 9x squared minus 49y squared. We can take the square root of both of these, and so we can rewrite this 3x, because if we take the square root of 9x squared, that would give us 3x, minus the square root of 49y squared, which would give us 7y. Then all we have to do is rewrite this and flip the sign. So pretty much you're writing the same two factors out. One has a minus sign, one has a plus sign. And that's really all difference of squares is. You just got to be sure that both of your two terms are perfect squares, and then it'll come out as the general form a minus b times a plus b, or pretty much you're rewriting the same two factors with one having a minus sign, one having a plus sign. All right, so now the next two things are going to be brand new. So we have something called the sum of cubes. It's very similar to difference of squares, but now we're looking at perfect cubes instead of perfect squares. So a perfect cube would be something like 1, 8, 27, 64, 125, and so on. So pretty much you can take the cube root of each of these evenly. And the rule for this is if we have a perfect cube plus a perfect cube, then this is rewritten a plus b times, we're going to take a and square it, minus a times b plus b squared. So you need to make sure you get that written down, because these will be a lot easier if you can just use this general form and rewrite it until you really understand the patterns. So we'll look at number 7. And once you see one of these, I think you'll see the pattern. They're not super complicated. I'm not going to really throw any tricky ones at you. But just make sure you get this down. So we've got x to the third plus 27. 27 is a perfect cube, and so is x to the third. So we can pull each of those out, or you could rewrite it like this if you wanted to. And actually, you need to rewrite it like this. So we've got x to the third plus 27 cubed, or the cube root of 27 would actually be 3. 3 to the third power is 27. So anytime you have those perfect cubes, you need to rewrite them as the actual cube root to the third power, because that 3 is what you'll use for b. So when we rewrite this, we'll write it x plus 3, because that's this a plus b part, times a squared, so we're using x as a, so it'll be x squared minus 3x, because we're just taking a times b and multiplying it, which we're saying that a times b is x and 3. And then that's going to be plus 3 to the second power, which would be 9. So that's how it would come out with the sum of cubes. And you just have to be sure anytime we're doing the sum of cubes, just write out, or the difference of cubes, make sure that this part here, you write out to the exponent of 3. So like 27 is a perfect cube. The cube root of that would be 3. So you would have to break it down to 3 to the third power to rewrite that. You basically need it in this format here, because that'll tell you what b actually is. All right, so let's look at the difference of cubes. This is very similar, except one is a plus sign here, one is a minus sign here. And that's why it's called the sum and the difference. So let's look at the rule for this. So the rule is we will rewrite this. If we get a to the third minus b to the third, we will rewrite this a minus b. Before we had a plus b up here. So it changes from a plus b to a minus b times a squared plus ab plus b squared. So essentially, you are changing two signs. You're flipping this sign here and this sign here from sum of cubes with difference of cubes. And we'll do an example of this one too. So we have 11. It is x to the third, so that's a perfect cube. And then 1 is always a perfect cube. We just need to rewrite this as x to the third in parentheses if you want, just to show that x is a, minus 1 in parentheses to the third power to show that you're actually using the number 1 as b. So then when we rewrite this, it will be x minus 1 times x squared plus, it would actually be 1 times x, which is just x, plus 1 squared, which is just 1. So essentially all you're going to do is make sure you can use this general form. And if you need to go through and label a and b, that's fine. But that is sum of cubes and difference of cubes. Now we're going to look at one more thing, or I guess two more things. I'm probably going to give you trinomials to where all you have to do is factor something out and then do difference, or then do the product sum rule. So like for number 16, you would factor out a w because each of these has w. So that'd be w squared plus w minus 20. And then you could just factor out the inside, which it would be w plus 5, w minus 4. So I'm probably just going to always give you ones like that, just so they're a little bit cleaner and easier to work with. But sometimes you're going to have sometimes you're going to have 4 terms, and you need to know how to do that. The way that we're going to do that is called grouping. It's not very complicated, but it's just, it takes some attention and focus to follow these steps. So make sure you follow each of these steps. So in the first step, it says group the first 2 terms together and the last 2. So the way that I would do that is just draw a line down the middle of these and split them up into parentheses like this. Now you can factor out a GCF out of each group. So if we look at this first group here, we can factor out an x squared out of each of those, and that will give me x plus 1. And then on the right side, we can factor out a negative 4, and that will give me x plus 1. You just have to make sure that these insides are the same, which they are. As long as those insides are the same, then that's going to be one of your factors. And then whatever's left in front of your parentheses will be what's in parentheses for your other factor. So you'd have x squared minus 4 and x plus 1, which we actually could simplify this even more, because this would be a difference of squares, which would be x minus 2, x plus 2, x plus 1. So all 3 of those would be our 3 terms once we factored it out. Sometimes you may not always be able to do that last step, but this is how you factor by grouping. So we're going to look at an example. And all the examples I'll probably make you do are, they're going to be pretty straightforward. So just be able to follow these steps. So the first step is to, when you have 4 terms or more, is split up your terms on each side. So split them right down the middle. So on the left side, we've got x to the third minus x squared. We can factor out an x squared out of that. And we'll be left with x minus 1 in parentheses. And then we can also factor out the right side, which we would factor out a 9. And that would give me x minus 1 in parentheses. So like I said, be sure these parentheses are the same. If they are, that means that this x minus 1 comes out as one of our variables, or as one of our factors, and then whatever's left on the outside of my parentheses that we factored out, that is our other factor. So we would have x squared plus 9 in parentheses times x minus 1. And we can't factor this x plus 9 out. That's not a difference of squares because this is a plus sign, so we would be done right here. So those are all the different factoring, like the types of factoring we're going to look at. This is going to be part 1. Next, we'll get into solving, but before we do that, I just wanted to make sure that we were all good on this. And really, the only new things are sum of cubes, difference of cubes, and then 4 terms, and factoring that by grouping. But I don't think you'll have too much problems with it, but we'll go over examples in class as well. We'll spend a few days on this.